Hi Starly, welcome back to this lesson. We want to look at this example 2. Okay, this is our second example. I want to see how we can also work around this question. So we did example 1 in the previous video. So let's look at this second question. The question is saying, in the diagram below, this diagram, the vector AO is equal to negative A vector. The vector AO is equals to negative A vector. You can see AO is opposing the direction of OA. So that's why it is given as a negative vector there. Then you have the vector OB. OB is equal to the vector B vector. Okay, so from there to there, that vector is equals to a B vector. Then we have ON. ON from here to there, it is equal to 1/3 of the vector OB. Now 1/3 simply means that we have 1 here, okay, and we have 2 here. So from O to N it's 1 unit, then from N to B it's 2 units. So if we add, we are going to get about 3 units. Okay, now since we are only concerned with the vector ON, so this will be 1 out of the total, which is 3, and of course of OB. So that's the vector here. The vector ON is equals to 1/3 of the vector OB. Alright, now they are saying that AP to BP is 3, 2. Okay, so AP is 3, so here let's just put these numbers, and then PB is equal to 2. Okay, so the total length of this line, so to say, is 5, right? And then from A to P it is just 3 out of 5. Then from P to B we have 2 out of 5. So here we have the following questions. Express the following in terms of vector A and or B, the following vectors. So we have the vector AB, the vector OP, and the vector AN. So that is part 1. Okay, so let's look at how we can find these 3 vectors here. So let's start with the vector AB. So vector AB, so the vector AB, so we are starting where? We are starting at A going to B. So the path that we are going to take here, we are going to say vector AB is equal to vector AO combined with the vector OB, right? So let's just create space so that we can see. So I'm saying solution. Okay, we are looking at the first part of the question. We are looking for the vector AB. Okay, so the vector AB is going to be the vector AO, okay, combined with the vector OB. Right, so this is going to give us the vector AO is negative A vector plus the vector OB is B vector, and so that's the solution there. So here we've actually we are done with that guy there. Okay, let's go to 2. Let me write it from here. Okay, what is 2 telling us? We want to find the vector OP. The vector OP, the vector OP. Alright, to find the vector OP, we can either use this path OB plus the vector BP, or we can still use this path, the vector OP, we can say it's OA, right, then AP. Either way it can give us the vector. Okay, so let's look at how we can get that one. So we have here vector OP. So here vector OP, it is equal to the vector OA. Then from A we go to the vector AP. Okay, let me just double check myself. So the vector OP is equal to the vector OA combined with the vector AP, right? Okay, so this is going to equal to the vector OA is vector A, then plus the vector AP. This is lying on this line where we have ratios. So here, since we are concerned with the vector AP, we are going to say we add these two numbers to get 5, and then we get 3 here, so that we can have the fraction 3 out of 5 here. So we are going to say that this is going to be 3 over 5 of the vector AB, this AB, because that is lying on the vector AB, so AB. So we'll say it's 3/5 of the vector AB. So here we have that. So this is going to give us A vector plus 3 over 5. Now what is this vector? It is this. So we have negative A vector plus B vector. Okay, we can just expand that. And so if we expand that, we are going to have A vector minus 3 over 5 A vector. Okay, then that is going to be plus 3 over 5 vector B. Okay, simplifying that guy, we are simply going to get the vector which is equal to 2 over 5 A vector plus 3 over 5 of vector B. So that will give us the solution for that answer there. Okay, for that question. So here, that is our vector OP. So this is vector. Okay, so this is vector OP. Okay, let's look at number 3. Okay, number 3, what is it that we are looking for? Want to find the vector AN. Okay, AN is very simple. AN, we can say this is going to equal to AN. We are coming to N. We are going to say it is equal to A O vector combined with the vector ON, right? Yeah, so we are going to do that. So AN vector is equal to the vector AN. Let's go back. AN is equals to AO vector, then ON. Okay, it's equal to AO vector plus ON vector. Okay, this is equal to negative A vector, that is for AO vector, plus 1/3 of what? 1/3 of the vector OB. Okay. Yes, 1/3, because this is vector OB. Actually, they even gave us right here. Okay, so we have that. Okay, so let's go back. Okay, so here we can just now simplify. This is algebra, so we have 1 over, where am I getting the plus or minus? So we have plus 1 over 3. The vector OB is just that. Okay, so here we can just try to hide that negative by saying we have 1 over 3 of vector B minus vector A. Okay, so we have something like that. Okay, if you want you can, but it's still okay even if you leave it here. But if you want you can play around this and try to simplify that, but it's okay if you leave it like this, it's fine. So here we are going to just underline it like that and say this is the vector A n. Okay, alright, are we done with the first part of this question, which is part A? Yes, we are done. Let's go to B. B is saying, given that OX is equal to h of vector OP, express the vector OX in terms of the vector A, the vector B, and h. Okay, so here what are we going to do? Where is OX? OX is here. Okay, we are going to X, then they are saying OX is equal to h of the vector OP, right there. Okay, so this the answer that we got here is coming into play. So here, I think let's have more space. So we are finding the vector OX, which is equal to h of the vector OP, right? Then here we are going to have h. Then here, just a matter of getting, what did you find? What did you get on OP? OP is this guy here. So we get 2 over 5a plus 3 over 5b. That's what we are going to have there. So, did we say 2 over 5? Is it a? This is supposed to be like that. Plus, is it 3 over 5b? Let's double check. Yes, we are right. It is like that. Okay, so here, the next thing is just to expand this, distribute this h. It's going to be 2 over 5 a vector h plus 3 over 5 b vector h. And so that is your answer in part B of this question. So that is the vector, oh goodness, so that is the vector OX. Okay, the last one, so this was B. Let's go to C. What is C? C is saying, given that the vector AX is equal to the vector AN. We know we are using this one here. Okay, express OX in terms of A, B, and K. All right. Okay, so here AX, let's start first of all by expressing that one. So we have they're saying, okay, next we are saying AX vector is equal to, is it K AN vector? Let's see, let's go back again. Yes. Okay, now the vector AN, I think we have found it somewhere. AN vector is here. So we are simply multiplying this guy by, is it K? What are we multiplying it by? K. We are multiplying it by K. Have I put? Yes. So here we are saying that this is going to be K, open bracket, AN vector. What was that? 1 over 3, 1/3 of B minus A, 1/3 of vector B minus A vector. Okay, we distribute the K. It's going to be 1/3 B vector K minus A vector K. Okay, so that's what we get here. Okay, once we get this one, the question is not done. We are still working around it. So remember, the question is asking us to find, to say, given that this is that, so we have expressed. Now we express OX in terms of A, B, and K. So what is the vector OX? Okay, so the vector OX now, the vector OX is going to equal to h of the vector OP. Okay, so this is now going to be the vector OX is equal to the vector OA plus the vector AN. Is it AX? AX supposed to be AX, not, yes, supposed to be AX, like that. Okay, so here what are we going to do? We say the vector OX is equal to, we know this is A, so this is vector A plus AX vector. The vector AX is same as K AN vector. Okay, because that's what we have here. Okay, then here we are going to have the vector A plus, what do we have there? We have 1 over 3 BK minus AK. Okay, do we have any like terms here? No, we don't, and so that will give us the vector for this particular question. So maybe you can just arrange it nicely and say the vector OX is equal to A vector minus AK plus 1 over 3 B vector K, and so that is now the final solution. I'm cutting my denominator, so I should be able to bring down this line here. Okay, like that is fine. Okay, so this is how you can work around vector geometry. There is only one particular question where I need to demonstrate, where they say show that given that this is this, show that this is like this. So I'll be able to also make a video for that one so that you see how it goes. Just algebra, you work around it. At some point you even factorize it, then you just arrange the terms nicely like that. Okay, so this is how you can work around the second question here. So I'm going to send series of questions that you are going to practice so that I see what you have understood from vector geometry here. So like I mentioned, this part of vector geometry is what is expected to be in paper 2 of ordinary mathematics. Okay, so see you in the next video.